Greetings of the day, dear students. I am Dr. Sarika Joshi, Assistant Professor at AISSMS College of Hotel Management and Catering Technology, Pune. Welcome to the Bridge Course Chemistry part. Earlier, we have seen multiple videos based on chemistry, which covered topics like the types of matter, the properties of matter, the effect of heat on matter, and another video which was based on boiling point and melting point related to the properties of matter. This session is based on another two properties which are related to the matter, and that is evaporation and condensation. The objectives of this session are introduction to evaporation and condensation, process of evaporation and condensation, and factors affecting condensation and evaporation. So let us begin and understand what is evaporation. So evaporation is a change in the state of a matter. It is a change in the liquid state of matter into vapor state without reaching at its boiling point, and that is called as evaporation. In the previous slides, we have seen that different material has different boiling point, and that depends on multiple factors. The stage of evaporation is reached just before the boiling point. Evaporation takes place only at the surface of the liquid, while vaporization takes place on the whole mass of the liquid. Evaporation takes place even at room temperature. Evaporation speeds up with the rise in temperature. These are certain characteristics of evaporation. With multiple examples coming in the upcoming slides, this process will be even better explained. Now let us have a look at the process of evaporation. So what happens when evaporation at the liquid surface? Molecules of the surface of water or any liquid, when is exposed to some temperature, their kinetic energy increases. Because of the increase in the kinetic energy, those molecules are able to overcome the force of attraction between the particles of liquid, especially water. After getting the required kinetic energy and decrease in the force of attraction, they escape in the air in the form of a vapor, and that is the process of evaporation in the diagrammatic form. So you can see that the topmost surface is exposed, and that's where the evaporation at the surface happens. It is continuously moving the water from the top surface to the atmosphere in the form of vapor. Now continuing further, let us have a look at what are the factors that affect the process of evaporation. Listed below are some factors which includes the temperature, the pressure, the surface area, that is the exposed area, the humidity in the air, and the speed of the wind. These are the factors that affect the rate of evaporation. Now, what is the correlation between the temperature and the evaporation process? Well, evaporation increases with the increase in the temperature, and it decreases with the decrease in the atmospheric temperature. This means that the rate of evaporation is directly proportional to the temperature. With the increase in the temperature, scientifically, the particles of the liquid at the surface get required kinetic energy to overcome the force of attraction and escape in the air quickly, and hence increase in the temperature increases the rate of evaporation. You can see that the temperature difference in the adjoining figure will show that the rate is faster when the temperature is higher. Moving ahead, what is the correlation between the second factor, that is the pressure, and the rate of evaporation? So, evaporation decreases with the increase in the pressure and it increases with the decrease in the pressure. That means it is inversely proportional. Evaporation and pressure are inversely proportional to each other. This means that the particles of the surface of the liquid require more kinetic energy to escape in the air when there is more pressure over it, and with this more pressure, automatically the rate of evaporation will decrease. While if there is a less pressure at the surface of the particular water body or the liquid, the particles would require less kinetic energy and they would easily escape in the air in the form of vapor, that is increased rate of evaporation. You can see the diagrammatic representation of the particular explanation, which mentions that increase in pressure slows down the rate of evaporation and decrease in pressure speeds up the rate of evaporation. The third factor which has a correlation between the surface area and the rate of evaporation. So what do you think, students? If the surface area is wider, do you think the evaporation rate will be faster? Well, yes. The answer is yes, the rate of evaporation will be better or more if the surface area is wider or bigger. Evaporation increases with the increase in surface area and decreases with the decrease in surface area. The evaporation takes place at the surface of the liquid, and if more surface is exposed to atmosphere, more particles will receive the required temperature to get the required kinetic energy and to escape in the air. On the other hand, if the surface area is smaller, lesser number of particles will get the surface area exposed and the rate of evaporation will be decreased. Hence, it can be concluded that evaporation takes place more rapidly with the largest surface area as given in this adjoining figure. There is yet another element that is proportionate to the rate of evaporation, and that is humidity in the air. So what is humidity? Humidity or the moisture content is the number of vapors which are entrapped into the atmosphere or the air. The evaporation rate decreases with the increase in the humidity and increases with the decrease in the humidity present in the air. It means it is indirectly proportional to each other. Humidity, as I said, is the amount of water vapor present in the air. In certain weather reports, you must have noticed that which are published in, let's say, newspaper or TV channels, the humidity percentage is shown which is nothing but the percentage of water vapor in the air. One of the major cities, that is Mumbai, is known to have more percentage of humidity, or any area which is near the coastal region is more humid since the rate of evaporation is extremely high. One more element that is related to evaporation is the wind speed, or the speed at which the wind is flowing. Evaporation increases with the increase in the wind and decreases with the decrease in the wind speed. This means the rate of evaporation is directly proportional to the speed of the wind. Speedy wind propelled away some of the particles of water with it and speeds up the rate of evaporation. And that is why the rate of evaporation increased is seen in the adjoining figure, wherein a fan has been put up near the liquid which is hot, and constantly stirring, you will see that the liquid evaporates faster and cools down even faster. Certain examples related to evaporation has been shared. We shall see some more examples at the concluding slide. To go further, another property that we need to understand is condensation and its process and the factors that affect the process of condensation. So let us first have a look at what is the process of condensation. Condensation is a process through which matter transitions from its original gaseous state into its final liquid state. For example, condensation happens in the vapor in the atmosphere when it is in the gaseous phase. It comes in contact with the colder surface and condenses onto water droplets. This process is known as condensation. Now we can understand that evaporation reaction stands in contrast to condensation. An alternative definition, hence, of the condensation is: condensation is any process in which two molecules combine while losing water. Condensation is a process of removing the heat from a system in a way that causes the vapor to turn into a liquid. So here the state is changing from gaseous to liquid state. Let us understand the condensation process. Condensation occurs when water transforms into a gaseous state to a liquid state, or sometimes a crystallized state. Any gas can condense at a high pressure and a low temperature. In theory, condensation can occur at any temperature as long as the pressure of the gas in its liquid state is lower than the pressure of the gas that is condensing. This is why, because the heat energy is removed during the condensation and the molecules in the matter eventually slow down. Now let us understand which are the factors that affect the process of condensation. So number one, when the temperature of the air is dropped to the dew point when its volume remains unchanged, that is when the condensation happens. It also happens when the temperature and the volume both are decreased. Condensation also happens when evaporation introduces moisture into the air. The drop of air is the circumstance that encourages the condensation to the greatest. Therefore, the quantity of cooling and the relative humidity of the air affect the process or the degree of condensation. The main factors that influence the condensation are temperature, pressure, humidity, and volume of the air. Let me quote another example to revise the process of evaporation. When heat is applied to a liquid or when a liquid surface area is exposed, the state of liquid that changes into vapor is called as evaporation. For example, when at the sea level, or if you keep some water in a bowl and keep it exposed to the air, you will see a decrease in the level of the water. Why is that happen? I am sure you have done this experiment in your school time. Yes, you are right. It is the evaporation that has happened there. Have you also noticed that the Indian bread, that is chapati, if been left exposed and not covered, will turn into dry state? Yes, that is because the water content in the particular food item is been exposed and is evaporated. So, the bread turns dry because the moisture content is lost. That means a little bit state of moisture or liquid has turned into gaseous, converting the actual property of the material. Let us now take example of condensation in our day-to-day life. You must have seen when the vegetable or the gravy is been prepared and you use the lid to cover the utensil, you will see a layer of water droplets on the inner side of that lid. What has happened here? The liquid is constantly boiling, and this boiling liquid state is going up and converting into gases. This is collected at the top of the lid, gets cooled down, and again converted back into liquid. And that is where condensation happens. You will see multiple such examples in your day-to-day life about evaporation as well as condensation. I am sure with these examples, the concept of condensation and evaporation are clear. We will see some more concepts in the upcoming slides. Till then, thank you so much for watching this video. Good day all.